All right, let's do our last lesson, I think, really of this unit. We've done the sampling methods, the bias, and then this is the third type of experimental design. It is called matched pairs. All right, so here is the objective that the College Board puts out and specifically states, but I break it down kind of into these next items. So let's just go through those. All right, so first of all, when you have many variables that you need to control, okay, when many items are affecting the response, then a matched pair design can be the answer to all of the controlling that you need to do. With blocked, that we just finished, there was just one particular trait that was obvious to us that we needed to control. Okay, but here we might choose to do a matched pair if there's really many items, 3 or 4 variables that are affecting that response we're measuring. So we'll take a look at those examples. Now, there are 2 ways that you can do a matched pair. One is with twins. Okay. And unfortunately, there was, a lot of scientific grounds made during the Holocaust because there was the angel of death doctor who was a German doctor, and he had instructed his the soldiers to look for Jewish twins because then he would take those twins and he would then randomly assign one of them to one treatment and one of them to the other treatment. Okay, and so at the hands of the Jewish people in the Holocaust, there was a lot of scientific grounds due to the twins. So here's an example. Say you want to use a type of beverage, Sprite or Dr. Pepper, and see which one does the best at tenderizing the steaks. So you would look for identical steak cuts, same size, same weight, same cut, same fat content, okay? And then you would take those 2 steaks and then you'd put them in a bag, shake well, or you could even do a flipped coin situation since there's just 2 of them. You're going to randomly assign them to either the Sprite or the Dr. Pepper. The twin situation happens most commonly whenever the twin is affect like the subject gets altered because of the treatment, and so then you cannot just like have it do the other treatment, and you'll see that with crossover design, and I'll talk about that. But here are steaks. We're going to get either tenderized by the Sprite or tenderized by the Dr. Pepper. You couldn't take them and then switch them and put them in the other one and see how that went. Okay, and that's what would happen with a crossover design. A crossover design is when the experiment, a subject is its own matched pair. Okay. And so this is happening because the subjects will do both of the treatments. Okay. But the randomization occurs is you would put all the subjects into a bag and see, all these subjects are going to do both treatments, but the difference is what order are they going to do them in? Because, for example, have you ever brushed your teeth after you've had orange juice? Okay. Or have you even, I don't like having syrup in with my pancakes after I've had orange juice. Okay. So there was something about the sweetness and the sour. If you have that sweet first, then that orange juice tastes horrible. So the order matters. Okay. So we want to make sure that that's not the issue, that the order is not affecting which preference the patients had or which one performed better and such. Okay. So here we go. So where the randomization occurs then is which treatment is performed first. So here's an example. A researcher wants to test which shampoo, Pantene or Garnier Fructis, provides the best volume for a subject's hair. Well, subjects will use shampoo for 1 week and rate the volume and the manageability of his or her hair. And then the subjects what you're going to do is put them in a bag, shake well, and you're going to have half of them do the Pantene and then the Garnier Fructis, okay? And the other half are going to do the opposite order so that the order in which they took them um, was not affecting the results. Okay. And again, this would be a good example of a matched pair because with a person's hair, there's so many things that go into the texture and the just what the person does with it and the types of things the person, how they like to do their style and all those different kinds of things. So many things with the person's hair, many treatments or many traits that we need to probably do a matched pair and just I compare my shampoo on my hair to another shampoo on my hair. All right, here we go. So let's write up these matched pairs and see how they are different. And so let's take a look at it. Let me get this thing here. All right, here we go. So the key is, so when we write up our matched pair, experiment, we're going to follow the same format, the SRAP me capped that we did with that completely randomized, but we have a few little changes at the front. At the top of it, we would want to say that we are going to make each subject its own matched pair, or we're going to have twins or whatever, because the many variables such as, and list a few of them, okay, have an effect on the response that we are measuring. And these are always in context, okay? So you have to be specific when you're stating what response you are measuring. Okay, and then you strap me capped. You say, for each matched pair, I'm going to start with them, I'm going to shake the bag, randomly assign them, and so on and so forth. And then at the end, which I think I might have left this off on my answer key, make sure you state, repeat the above experiment within each matched pair. Um, and so we'll read through my experiment that I wrote and see if that makes if that was needed or make sure that I included it. This just reiterates that each pair is its own experiment. So each pair is its own little experiment. All right. Okay, this is important. Make sure you notice that, just like with the blocks. Remember with our blocking dogs, I wouldn't compare the collie's results to the Dalmatian's results, okay? Because that's why we separated them, because the dog breed is having an effect. Well, same thing here. I'm not going to compare someone's hair preferences to my hair preferences because that's why we separated it, because to each his own personal preference. Okay. All right, here we go. Let's start this experiment. So, to review, what is the purpose of matched pairs? And that is to do like our blocking does. It reduces the variation because it's blocking all the subjects that have that common trait together. So me, I'm my own pair, so there's no variability there. If I'm my own matched pair, the only difference that is happening from one treatment to the other is the treatment itself. See? All right. We typically use matched pairs rather than just blocking by one trait if there's those multiple traits that we want to control. All right, how do you know if you should use the match pairs? Well, again, you have those multiple traits, not just one trait that we controlled with the randomized block. All right, so here we have this situation. Let's go through this example. We've got an educational psychologist who wants to compare and test two different memorization methods and compare their effectiveness to increase their memorization skills. But we do have, 120 subjects available, ranging in age from 18 to 71. Okay. But as I'm sure you can imagine, the psychologist is concerned that there's differences in memorization ability just based on the person themselves due to age, education, IQ, many things. And so those could confound the differences between the methods. Okay. So let's talk about how that might best be done. The experimental units, of course, those are those 120 subjects ranging from 18 to 71. We are intending on testing the explanatory variable of those two different memorization methods, okay? And of course, with pairs, it's worth noting with matched pairs, there can only be two treatments because you get a pair, okay, a twin, and you can just have one go to one treatment and one go to the other. So you can't have matched triplets, or at least in this course, we don't go further than just a matched pair. The response being measured. Well, it's set up there. We are measuring that memorization improvement. Okay. So state the parameter of interest. All right. Well, they didn't exactly tell me how they were measuring their memory progress. So I myself had to kind of imagine that as, a series of tests, and then you would maybe get a percent of the ones you got correct or whatever. So in my mind, the results I would be getting in a memorization test were numerical, a percentage, or well, don't want to say percentage, but a numerical of how many you got correct and so on. So I imagine that the assessment on memory improvement would create that number value. So you're going to get a score to determine how much the memory has improved from before to after. Therefore, the parameter of interest is the average difference that memory improvement did between those two memory methods. Okay, the average, because I figured it'd be numerical. All right, so state the variables that may confound the response. What could confound the issue and cloud it so we can't see the effects? Well, those are those things I mentioned, such that we have more than just one trait that we need to control. We need to control multiple traits such as age, education, IQ. Okay, all right. State the type of matched pair design you want to use and why. Okay, so with that question, I'm asking, are you going to do a twins? Okay, where we have two people that are identical in all those ways, or are we going to do a crossover where each person is going to do both? Well, you could probably you might be able to find twins. They're close in age. You have 120 to choose from. So you might be able to find two that are matched most closely in age and education and IQ. I chose crossover. I'd use crossover design. Each subject has many traits, and I think it would be difficult to find two subjects that are matched closely in all of those traits that would confound the experiment, such as age, education, IQ. I'm also concerned that the second memorization method used might seem better just by virtue of it being second. So, therefore, I'm going to rely on randomness to spread my subjects evenly to, this group will do one method first, and then this group will do the other method first. Okay. You don't have to state that when we're doing our experiment, but we just need to talk through. That's what's happening. That's what I'm working on controlling. All right, so let's do this. Here we go. Design the appropriate experiment. So here's how it starts. Remember with our randomized block, we me capped. Well, this is me capped, so I'm going to make each patient its own matched pair so that's kind of what's happening. I'm making them their own matched pair because each subject has many traits such as age, education, IQ that may affect the memorization improvement. Okay, so I'm telling what I'm going to do and why, and I'm referencing the specific response I am measuring. All right, now I'm going to start with the 120 subjects ranging from 18 to 71. And I'm going to randomly assign those 120 subjects by putting them in a bag. Here's my asterisk. Putting them in a bag, shake well, and pull out 60 of them to go to treatment group 1 and 60 to go to treatment group 2. The reason I wrote it like that is because then I elaborate. Treatment group 1 will go through the first memorization method first and the second memorization method second. Treatment group 2 over here we'll do the opposite order of the memorization methods. Okay? So there's my R, my asterisk, and my T for treatment. So now we're going to ME, measure each subject's memory improvement or response due to the memorization method. Okay. And then I want to, so this is interesting. So each person's doing two of them. I need to then, like me personally, I need to see how much better did I do on one of them than the other. So once I get my results, my number improvement for test one and my number improvement for test two, I need to subtract that and see what's the difference between how I did on those two methods. Okay? How did the improvement of method one differ from the improvement of method two? And so I'm going to end up with, and so I even said I'm going to do method one minus method two. We'll get into the mathy part of this later. So if this to me gets a little scary because we're not into, once we do next semester and we talk about a matched pairs design, this will make a little bit more sense. It seems a little overbearing right now, the language of it. But in summary, then we will average those differences between the memory improvements of the two methods to see if there is a significant difference in that memory improvement of the two methods. Okay? That's it. So MUBRAT me capped is all you got to go through. MUBRAT me capped, making each subject a match pair because of many traits and name them. All right, I think that's all for matched pairs. Now there's one last little thing, and I think I'm going to separate that video. So the next video we're going to be talking about this idea of that statistically significant. So let me separate that into its own. All right, final experimental design, yay!